All right, let's talk about adapting large language models. We all want to get these incredibly powerful tools to do specific tasks for us, but doing it without, well, breaking the bank or melting your GPU is the real trick. Today, we're going to dive into a really clever way to do just that. It's called prompt tuning. Right, so you want to get these super powerful LLMs to do a specific job for you, but you immediately run into this classic problem. On one hand, you could do a full fine-tuning, which is amazing, but it costs a fortune, both in time and compute power. Or you could go the other route, just write really, really long detailed prompts. That's cheap to set up, but man, it gets costly every single time you ask the model a question. It feels like you're stuck between a rock and a hard place. So, is there a better way? Okay, let's really put these two side by side. You've got these two extremes, right? With prompt engineering, your training cost is pretty much nothing. But the inference cost, what you pay for each question, can really add up because you're just stuffing so much text into the prompt every time. Then you have full fine-tuning. Here, the training cost is just massive, but once it's done, asking questions is super efficient. The problem, the huge catch, is that you end up creating a whole new gigantic model for every single task. That's just not sustainable. And that right there, that's the heart of the problem. It's the adaptation dilemma. But what if there was a way to, I don't know, have our cake and eat it too? A hybrid approach that gives us the best of both worlds. Well, there is. And that's exactly where prompt tuning comes in. It's this super elegant solution that finds a really smart path right down the middle. So what is this thing? Well, put simply, prompt tuning is a technique where instead of rewriting the model or writing a novel-length text prompt, you actually train the prompt itself. Think about that for a second. We're not messing with a giant billion-parameter model at all. Instead, we're training a tiny, tiny set of what are called soft prompts, or virtual tokens. These are like secret instructions that tell the original frozen model exactly how to act for our specific task. Whoa, hold on a sec. How can you tune a model if you don't actually change the model? It sounds like you're just fiddling with the input. How in the world does that actually work?
You hit the nail on the head. That is the magic of it. And the process is surprisingly simple when you break it down. Step 1, you tack on a few of these new trainable virtual tokens to your input. Step 2, and this is the absolute key, you freeze the core LLM. You lock it down. Not a single one of its billions of parameters gets changed. And then step 3, you train only the new tokens. That's it. You're basically teaching the model a new secret language that's hyper-optimized for your specific job. And the most important thing to get here is that the base model's brain, all of its original knowledge and reasoning power, is completely untouched. It's still the same powerful model. All we're doing is learning a super efficient new way to talk to it. The key phrase to remember is this: you're not touching or modifying the model's internal weights in any way. Okay, I think I'm getting it. So we're basically creating a special language just for one task. But why is that such a big deal? What's the real payoff here? The payoff is efficiency, and I'm talking about efficiency on a scale that is honestly kind of hard to wrap your head around. Just look at the raw numbers. When you do prompt tuning, you are freezing more than 99.9% of the model. You're only training this tiny, microscopic sliver of the total parameters. How tiny? Well, in one of the key research examples, the number of parameters they actually trained was just, get this, 0.00366% of the total model. No, that's not a typo. We're talking about a completely different universe of computational cost compared to full fine-tuning. It's just orders of magnitude smaller. And that incredible efficiency is what unlocks all the cool benefits. For starters, it completely avoids something called catastrophic forgetting. That's when you fine-tune a model on a new task and it just forgets how to do the stuff it was originally good at. That doesn't happen here because the original model is safe. It also means you save a ton on tokens when you're actually using it. And this is the really exciting part: it lets you create these tiny, task-specific adapters. Yeah, let's look at those token savings because this is huge. On the left, that's what a prompt-tuned query looks like. Short, sweet, to the point. On the right, that's your typical few-shot prompt. It's loaded with examples, instructions. It's just a wall of text that eats up hundreds of tokens. With prompt tuning, all that complex instruction is basically compressed into those little virtual tokens. So your actual prompt is way shorter. And that saves you real money and time on every single call. Okay, that adapter idea, that sounds like the real magic trick. So you're saying I can have one giant base model,
and just use it to do a bunch of totally different specialized things?
Exactly. And this is where it stops being a cool lab experiment and becomes a total game changer for real-world products. So picture this. You've got one single, massive, resource-hungry model loaded up and running in memory. Okay, now you get a request that needs an expert prompt generator. No problem. You just load up adapter A. That's your tiny set of virtual tokens you trained for that one job. But then, literally the next second, a different request comes in. This one needs to classify text for hate speech. Again, easy. You just instantly swap out adapter A and pop in adapter B, a totally different set of tokens trained for that job. So the bottom line is you're running all these different, specialized, fine-tuned tasks from a single model. All you have to do is switch out these tiny, lightweight adapters on the fly. The savings on memory and infrastructure are just astronomical compared to the old way of loading up a whole new, massive model for every single task. Okay, let me try to put this all together. So basically, we're taking the giant model and putting it on ice, or freezing it. Then we're creating these tiny, swappable prompt plugins that teach it new tricks really efficiently, all without ever messing with its original brain. Is that the gist of it? Prompt plugins. I love that. That's a perfect way to think about it. It's like having one really powerful universal drill, and then you just create a bunch of tiny, specialized bits for it, instead of buying a whole new giant machine for every single type of screw. You're adapting the input, not rebuilding the entire machine. And that really brings us to the big picture, doesn't it? If we can essentially bottle up these incredibly specialized AI skills into tiny, efficient plug-and-play adapters, what does that really mean for the future? How does that change the game for making custom AI accessible to, well, to everyone, for literally any task you can dream up? And that's our look at prompt tuning. Hope you found that helpful. If you did, you know the drill. Like, share, and subscribe so you don't miss our next deep dive. Thanks for watching.